Okay, just like we have the data types for integers, excuse me, and we also have the data type for floating point numbers. We have another data type that is the character data type, is the char data type. This one is used to hold single characters or very small integer values. The size of memory that it's going to be using is going to be just 1 byte of memory. 1 byte of memory. So that means if I have 1 byte, how many signals do I have? How many bits do I have? 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. If all of them are on, this will be a value of 255, right? We have all of them on. Starting with the 1, the 2 is on, the 4 is on, the 8 is on, the 16, the 32, the 64, the 128 are on. So they are all on. So the only thing that I can store in 1 byte is going to be 255 different characters. That's it. So that's why it's going to be a single character. And a single character, if it's a constant, is going to be enclosed in quotes, in single quotes. So let's see. If we have the letter C, remember, inside main memory is not going to be stored as the letter itself. It's going to be stored as signals representing the letter C. So if it's going to be a 67, we know that it's going to be the representation, decimal representation is going to be 67. So then it's going to be, we have 3, 2, 4, 5, one more right here, and that is going to be the representation. Those are the signals that are going to be representing the letter C. On, off, 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 on, off. And that is going to be representing the letter C, the capital letter C, in main memory. So it's just going to be 1 byte. So this is, for right now, the smallest representation that we have. Because we know that if it's going to be like a double, it's going to be using how many bytes? 8. If it's going to be an INT, how many bytes is it going to use? 4. But if it's a character data type, then it's just going to be using how many bytes? 1. Only 1 byte is going to be used by the character data type. When we're working with a character constant or a character literal, it's going to be a single character. It cannot be more than 1. So this is going to be always enclosed in single quotation marks, So if I have hello, is this a character constant? No. If I have the H, is this a character constant? Yes. If I have the asterisk, is this a character constant? Yes. So am I going to surround hello with single quotes? No. It has to be with double quotes. What about the H by itself? Am I going to surround it with single quotes? Yes. How about the asterisk? Am I going to surround it with single quotes? Yes. As long as it's one character, then it has to be surrounded by single quotes. And the name tells you, single character, single quotes. More than one character, then I'm going to change to double quotes. And we're going to find out why in a minute. When I surround the character in single quotes, the quotations mark are not going to be part. Okay? of that character. They are only going to tell the control unit, hey, this is a single character. That's the function of the quotes, of the single quotes. It's sending a message. So if the central processing unit is reading this line, it's going character by character. As soon as it finds this one, it's going to say, oh, okay, I have a single character here, so I need 1 byte of memory to store it. And it's going to separate that. Yes?
So it's a single line, not all of the what you put in?
It's a single byte, not a single line. It's a single byte, because remember, main memory is a grid, right? So each box, we can visualize this as a box that has 8 signals right here. So it's just going to be using this little box to store the letter Y. If I say, okay, this is a double number, how many bytes is it going to be requiring? 8 bytes. So it's going to be using 1, 2, 3, 4, 5, 6, 7, 8. 8 bytes to save my number, to store my number in main memory. Of course, all of them are going to have 8 bits. So it's going to be a very large amount of space in main memory, right? Versus 1. Look at this. This one only uses 1. The other one uses this much. Any other question on this? Okay, now, if we're going to be talking about constants, we know that if it's a character constant, we're going to surround it by single quotes. If it's a character that is, if it's 2 characters or more, they are going to be surrounded by double quotes. And we call them string constants or string literals. They require double quotes. And the reason that they require double quotes is because they are going to send a signal, okay, to control unit, and they're going to indicate each one of these characters requires a byte of storage. Requires a byte of storage. And you're going to stop at the very end when you find a null terminator, a stop sign. So if I have the word hello, this is going to require how many bytes? And the first byte, what am I going to be placing? The letter H. The next byte is going to have the letter E. The next byte is going to have the letter L. The next byte, again, another L. The next byte is going to have the letter O. And then I have one more that is going to be used for the null terminator. That indicates this is it. This is the stop. So how many bytes do we have? 6. If I'm going to be storing COSC space 1336 section 2. This is my string. How many bytes do I use for this? 13? Why 13?
One for the terminator and one for the space.
Okay, so we have one for the C, one for the O, one for the S, one for the C, one for the space, one for the 1, the 3, the 6, the dot, the 0, the 2, and then of course the terminator. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different bytes that are going to be reserved for this message. Why? Because it has the double quotes. If I put double quotes, A, double quotes, how many bytes are we going to be using to store the letter A? 2. Just because I put the double quotes, this is not a character anymore. This is going to be considered a string because the double quote is sending that signal to the control unit and is saying, this is a double quote, so what follows is going to be a list of characters. So the A is going to be stored in main memory as A and then the null terminator. Of course, the null terminator is never going to be shown to us. That's just internal process. That's how the CPU is going to be able to determine this is the end of a list of characters. This is the end of a message. This is the end of a code. This is the end of a description. This is the end of a flight number. This is the end. Okay? So it's going to be there to indicate the end of a list of characters. Questions? So we need to remember, this is just so that we can review, a character literal, it's a single character always, and it's going to be enclosed in single quotes. A string literal or a string constant is a sequence. Okay, remember it's a list, it's a sequence of characters, and they're always going to be enclosed in double quotes. So when I enclose it, just the example that I gave you right now, when I enclose a single character in the double quotes, then it becomes a string literal. It's not a character anymore because of the null terminator that is going to be added. Just like we have data types for integers and for absolute value numbers, we also have for character, right? We also have for byte, for strings, for this type of messages, for sequences of characters. And in order to work with that, we're going to be using a directive that is called string. The string is going to be used when I work with more than one character. So I need the string in order to create my variables. They are going to be called string variables. They are not pure string variables. They are objects and they are instances. But for right now, we're going to call them variables. But I want you to keep this in mind, that this is going to be creating an object, right? And the object is going to be creating the variable or the instance. So if I'm going to need a place in main memory to store, like in this case, a name, then I need a variable. Just like when I need to store a number, I need a variable that can be an int, or it can be a double, or it can be a short, or it can be a float. So I also need a space in main memory, and I need to name it, because the name is going to be the location. And I need to say how many characters I need. But because it's a string, it's very difficult to know how many bytes I'm going to be using. For int, I already know that it's 4. For double, I already know that it's 8. For character, I already know that it's 1. But for string, it depends on what I'm going to be putting in there. It can be hi, and it's only 2 characters, or it can be hello, and it's going to be more than 2. So which one how much do I reserve? The computer doesn't know. So what we use is this program that is going to help us with that. So we don't have to worry about counting and saying I need this many bytes, because this program is going to do it for us. The only thing that I need to do is call it, include string, and then create a variable that is going to be a string variable. So this is going to be reserving a space in memory, X number of bytes. It's just going to say, hey, I'm coming with something, so just reserve me X amount of space here in memory because I'm going to be needing a lot. So when we move this name, George, to the variable called name, how many characters or how many bytes are we using in main memory? It's going to be 1, 2, 3, 4, 5, 6, and then the null operator, right? If I send the name, close quotes, double quotes, J-O-E, double quotes, how many bytes am I going to be using? 4 only. 3 and then the null operator. So what happens is this name is going to be stored right here. Name is pointing at the beginning, remember, and then it's saying 1, 2, 3, 4, 5, 6, and then the null operator is going to be here. So when we have cout, my name is, and then this box, what is this box? It's a variable, which has what? Is it going to display the word N-A-M-E? No. What is it going to display? George. It's going to display the value George. Questions? Okay, open up Visual Studio. And Word, please. And I'm asking you to open up Visual Studio because it takes a couple of minutes to upload. But of course, we're always going to start with Word, right? Or with any other text editor. Okay, let's suppose that we are asked to create a program. So we're going to be creating a program that displays your name and your address. The name and the address are stored in 2 variables. So that's where we're getting them from. So we're going to create a program that displays the name and your name and your address, but the name and the address are stored in variables. They're going to be in variables. So that's where we're getting them from, okay? From the variables. Everybody understands that? Erica? No. Create a program that displays your name and your address. But the name and the address are going to be stored in 2 variables. That's where we have them. Okay, so the way that I'm visualizing this is we're going to have a screen. And in this screen, I'm going to write the message. My name is, leave a space, and then whatever that is. My address is, and then whatever that is. That's how I wanted to see it on the screen. Okay, remember, we have to understand the project. That's the first thing. If I don't understand what this is, then I'm going to have a hard time because I don't know where I'm heading. So I need to write a program that displays my name and my address. Where's the name? Where's the address? They're going to be put in variables. What is a variable going to be placed? In main memory. So it's going to be there, inside main memory. So I need to grab it from there and send it to the screen. Am I just sending the name? Am I just sending the address? No. I want to have a prompt, like this one. My name is, so that I know what that is, what I have next to that. I want to put here the message, my address is. That's what a prompt is. It's a message explaining what we have. Okay, everybody with me? No questions on this? Sure? If we don't understand again what we're doing, then we can write the code because you're going to be copying what I'm going to have, but that's not what we want. You did not accomplish that goal, right? Because you're just copying what I have here. We need to understand this. So I'm going to ask again, do you have any questions? Okay, so how am I going to solve this? Step number one, what am I going to do? They cannot, if they are not in order, that's fine. We can rearrange them. What do I need to do to accomplish this, to get this on the screen? I need to do what? Okay, I need to include the subdirectories. So which subdirectories do I need? IOStream and string. Why? Include why IOStream? Why string? Why do I need IOStream? Again, I'm going to repeat it. Because I'm going to be displaying something on the screen. That is correct. I cannot display anything on the screen if I don't have the IOStream. And what do I use to display on the screen? I use the cout. So that means the cout cannot work if I don't have IOStream. What about string? Why do I need string? What? To use string objects? You were going to say something over here? Because we have to use string variables. That's correct. Both of these answers are correct. I'm going to be using string constants, right? My name is more than one character. Or raise your hand if your name is only one character. Your address has more than one character? Yes. So whenever I use string constants that are going to be placed where name and address are stored in variables. They're going to be stored in variables. So if I'm going to be placing my name that has more than one character, I'm going to be placing my address that has more than one character in variables, then I need to use the string directive. Yes, everybody with that? Fine? Is that no problem with that? Okay. So now after I do that, what else do I need to do? Because just by including those directives, I'm not going to be able to get this out. Okay, I need to define the variables. And remember that the variables are what? Memory locations, right? They're memory locations. How many variables do I need? Two? Okay. What data type do I need to use? String. Remember the data types that we have. Who wants to give me one? Data types. INT. What else? Float. Double. Long. Okay. Short. What else? Another one. Long double. Okay. I have 7. Give me another one. Long int. Well, I think we already mentioned that one. The signs, yes, we have all the signs for all of them, INTs except the double float. We're missing 2 that we already talked about. And yeah, all the sign and unsigns are included. String, and we're missing just one, that character, the chart. Okay, of all those 8 that you just mentioned, what type do we need to use for this program? String. Okay, I wanted you to name them so that you remember, because you always need to check your list. Okay, I have short, INT, long, I have float, I have double, I have long double, I have character, I have string. Of these ones, which one do I need for the name that I'm going to be putting in there? Is it going to be an INT for a name? Is it going to be a short for a name? Is it going to be a double for a name? No. So every time that you create a variable, you have to check your list and say, what can I use? So to hold the name, define the variables. So one of them is going to be, I'm going to put here, is for the name of the student. I need what? What type? Of those 8 that we mentioned. String. And we also need to say string, but we also need to give it a name. Okay? We need to give it a name to that variable. Because remember, the name of the variable is going to be the pointer. Is going to say, okay, I'm pointing at this location. So give me a name. Okay, name. I'm going to be adding just my. My name. Okay, this one, define memory locations. One is the name of the student, and it's going to be a string, and it's going to be called my name. Do I need another variable? Yes. If this one is for what? It's for the address of the student. Okay, what type do I need? String as well. String, and it's going to be called my address. Okay? Everybody with me? Not in the typing. I don't want that. I want you in that you understand what I'm explaining. Questions? Comments? Complaints? Okay. Let's continue then. What else do I need to do? Because this is not going to display anything yet. Display what? Okay, display the message. My name is. What else do I need to display? The what? The variable. Okay. And the variable my name. Okay, is that correct? Yes? Positive? Like if your life depends on this? Yes? Okay, let's see. We have here, we're going to be including two directives, IO and string. That's okay. We're going to define memory locations. When I define memory locations, that means I'm going to be creating two boxes, right? Or one box in this case. Okay, I'm going to put my box right here. So I create a box. This is going to be for the name of the student. So I create my little box. There it is. And it's going to be called my name. And the only thing that I'm going to be able to put in there is going to be characters, 2 or more, because I already have a string right here. Do I have something inside the box? No. And then you tell me display my name is and the box. What do I have? What do I have inside the box? Nothing. What am I going to be displaying? Nothing. The box is empty. So you're displaying nothing. You're displaying the message, my name is, but then blank. Is that what we want? What do we want to display? Whatever it's inside the box. So what do we need to do? Put the name inside the box. Assign the value. Where? In step number 4? Before that. So before step number 3, I need to move the name of whatever that, I'm going to put my name here, Blanca, to my name. And then I display it. So now I create a box. Okay, here it is. Here's my box that is called my name. And then I move Blanca to my name. So this box is going to have Blanca inside. So now when I display the message my name is and the variable my name is going to display this, Blanca. It's not going to display MYNAME. Okay? It's going to display the contents of my name. Questions? Okay, next step, what do I need to do? What same process? Include the directives, define the variables, move the address, the actual address, right? So I'm going to put 80 Fort Brown. Where? My address, to that box. Then display my address is, and what else? And the variable my address. Okay, after that, end. Okay, check the logic and tell me if this is okay so that we can start with the code. Remember, the last step here is you have to check. I checked it right here when we made the correction because I didn't want to continue without that correction. Okay. But now that we finished, we need to check it again to make sure that it works step by step, as if you were the computer. Okay, we call this playing computer, to make sure that it works. Logical errors, yes. That will come after n. No, the logical errors is you just play computers. You follow the instructions and see if you're going to get this. Do you think this will work? This pseudocode? Yes? Okay, so you give it the okay. We are ready now to start the code. So remember, the code is going to be whatever we have in this pseudocode, we're going to put it in code now. So we open up our Visual Studio. And we're going to start a new project. Win32, make sure that is Visual C++, console application. And we're going to call this display info. I'm going to click on next. Console application, make sure that it's on. Empty project, make sure that it's on. And then finish. We move the cursor to the display info, right click, and we're going to be adding a new item, which is going to be our code, right? So I select in C++, I select code, C++, and then I'm going to use the same name, display info. No spaces, no special symbols, please, on the name. So we have the editor. And we're ready to start. The first thing is I have to write my description. So I already have it here. In my plan, I'm going to just copy this and paste it in my comment line. I'm going to put it in 2 lines. So now I'm ready to start with my pseudocode. Include the directives. How do I include directives? Using now C++, line number 1. Okay, so I use my pound or my hashtag include. Then the angle brackets, IOStream. So I find IOStream, here it is, close the angle bracket. Okay, that's 1. Do I need another one? String, I have it here, right? Right here, IOStream and string. So I start again, pound, include, then angle brackets, and what am I going to be including here? String. String, here it is, angle brackets. Do I need another one? No. How do I close my includes? Do I finish with a semicolon at the end of the last include? After what? After string, right here? Do I close it here? No, I see some of you that are saying no. Why not? What is the ending line for all my includes? A line that I always have to use. Using. I cannot end an include with a semicolon. I always have to close all the includes, even if I have 50, okay? They're all going to be listed. Pound include, pound include, pound include, pound include, and the last line has to be using what? Namespace. What else? STD. And now I close my semicolon. So the beginning is right here and the end is right here. Okay, so I have now line number 1. This one, I did it. Next line, what do I have? Define variables. What is this going to happen? Define of the variables, move the name, move the other one, display, display. Where is this going to happen? Inside main. Everything has to happen inside main. So I have to start my main, int, main, open and close parentheses. I use my open curly brace and my close curly brace. I have both right there. I always start with that so that I don't forget to close the last one. So in here, I'm going to do step number 2, number 3, number 4, number 5, number 6, and number 7. So let's start with number 2. Define variable locations. I need to define a string, one for the name of the student that is string, and it's called my name. And I need to define another one for the address of the student that is also string, and is going to be holding an address, and is going to be called my address. Okay, so how do I start this? Okay, I don't remember. I go to my PowerPoint presentation or to my book, and they have something here about variables. Let's see, where is it? See out. Variables. Variable has a name and a data type of data it can hold. How do we do it? This is the example. What did they use? First, what? Data type. And then the name. So if I'm going to be creating a variable, and I already have the information here, what am I going to use? String. That is the data type, right? And then the name, right? Which we already decided that is going to be called my name. And then I close with a semicolon. That's what I have here in the presentation. And then you close with a semicolon. It's here. No magic. Okay, next line. Okay, string, bless you. My address. Semicolon. Then I have to do what? I'm done with line number 2. Let me just highlight it. So I'm done with line number 2. Line number 3, what do I do? Move Blanca to my name. So how do I move something to a variable? What operator do I use? What operator do I use? The assignment operator. Has a single variable to the left side and a value to the right side. It's right here. Everything is right here that you need. So if I'm going to need to move Blanca to my name, how do I write that line? Okay, my name, assignment operator, and then the name, your name. You put your name. I'm going to write my name. Okay, so my name is Blanca, like that. B-L-A-N-C-A. 1, 2, 3, 4, 5 characters. What do we know about putting characters? A list of characters. They have to be surrounded by double quotes. So Blanca must be surrounded by double quotes. This is it, and I press the end of my line symbol. Semicolon. Not if I follow my pseudocode. Line number 4. Display the message. My name is, and the variable my name. So how do I tell C++ that I need to display? Cout, cout, and then what do we call this? The output stream operator. Okay, output stream operator. After that, what do I want to display? Okay, quotations. Okay, the message, my name is, close the quotes. That's it? No. What else do I want to display? The variable my name. Okay, but before if I'm going to be sending another value, I need my output operator. And then my name. After that, what I have here in my screen is I skip a line, right? So after my name, I'm going to send also a break line code. So I'm going to end line. And then I close it with a semicolon. Okay, everybody with me? Questions on this? Again, remember, the objective is not for you to copy this. The goal that I have is for you to understand what we're doing here in this program. Next line is going to be, okay, my address is going to have what? 80 Fort Brown, or your address. And then I'm going to display. So I'm going to put cout, my address is, close the quote, open up another operator, output operator, and I'm going to be sending my address and the end line. And I'm ready to finish. The end. How do I say end in C++? Return 0. Not 0. Control F5. Okay, it's taking its time. Who got it already? Did it very good, very good. So what I want you to see is the information that you got. Is it similar to what we have here in our visualization? Yes. Okay, did you leave a space? No, the space has to be inside the double quotes. Do you have a space inside the double quotes? No, that's why it's there next to the is. The spacing outside the double quotes is not going to affect the display because you're telling the computer, display this. There it is. My name is Blanca. My address is 84 Brown, right here. Exactly the same as I have these two lines. Okay, questions on this? Questions on the process? Okay, let me show you something. What if I remove the IO stream? This one right here. What is going to happen? IO stream is gone. IO stream is needed to display, right? Bless you. What is going to be marked as an error? The cout. It's there. It's saying, hey, I don't understand what cout is. It's undefined cout. It cannot be recognized because I'm missing my include. What if I remove the string? I'm going to cut it out. It's no longer there. What is going to be wrong now? All my name is not going to be recognized. Everything is going to be giving me an error. I'm going to paste it back in. Okay, what if, remember that we created the my name, but we did not put a value in it? I'm going to remove this. And I'm going to run it, even though this takes a long time. Let's see if this time it goes faster. It's going to display my name and then emptiness, right? It's going to display the address, but it's not going to be displaying Blanca because I did not put it in there. Change this program and instead of your address, display your GPA. Display your GPA. We still have a couple more minutes to do it. Yeah, to the GPA. Okay, just to show you, here is the output with my name and it's empty right here because I'm missing the putting the name in there. Remember that the GPA is a numeric value. Create a program that displays your name and your GPA. The name and the GPA are stored in two variables. Who changed it already? Okay, can you guide me? What do I need to do here? Change my address? What did you change in your program? Tell me what you did. My address, what do I do with it? The value, right here? Uh-huh. Type the GPA, 3.1. Okay. This will work. If 3.1 is not going to be used, and then change this, my GPA is, right? If the GPA is not going to be used for an arithmetic operation, but I specify GPA is a numeric value. So in my string, I don't want to put a 3.1. What do I need to do here? Remember I told you, whenever you're going to put a value, you have to think of the variable and list all the 8 data types that we know so far. We know short, int, long, float, double, long double, character, and string. Right? So which one of those do we use? Double. Let's use double. Or float. It's fine. Double, and I'm going to put my GPA. Just because I want to make sure that my variable reflects what I'm going to be putting in there. So now my GPA is going to have, do I need quotes for the 3? No. It's a numbers never use quotes. And this is going to change. Instead of 3.1, it's going to be GPA. I'm going to run it. And it's going to display my name and my GPA after a couple of minutes. So this is the output for this program.